Hello and welcome to Clear as Mud, my YouTube channel dedicated to learning and teaching in academia. My name is Kush Bubber and I'll be hosting this video. Speaking of videos, this one's part of a series I'm calling Explaining My Work, where the focus is on describing academic papers I've published using clear and pragmatic language. Hopefully this reduces the time you spend reading and gets you back to doing more important things like writing your thesis. The paper I'm talking about today is The Evolution of the Design Engineering Mentorship Program and focuses on the development of a training protocol for graduate students teaching engineering design at the undergraduate level. This work was presented at the Canadian Engineering Education Association's annual conference at Dalhousie University in Halifax, Nova Scotia, Canada. The full paper is available at my ResearchGate site, and this URL along with details about the conference are posted in the video description below. Before I get started, I wanted to pay my respects to Clive Dim, who passed away earlier this year. Professor Dim was a strong advocate of engineering design education and is one of my primary references in this work. Moving on, this presentation will start with a program overview which includes both the motivation for the program along with a description of the educational psychology behind the decisions in developing DEMP. This is followed by a brief overview of my team and descriptions of the workshops delivered within the training. Finally, we finish with a design project challenge and delivery. Program overview. All good research is motivated by challenges, and our work is no different. In our case, we have 3 challenges: growing engineering undergraduate class sizes, offering of more design courses, and larger emphasis on teaching engineering design. All 3 are positive signs of growth in engineering education. However, they are eclipsed by the reality of limited budgets. Ultimately, the issue comes down to resources. We decided to explore the resource challenge further. What about using graduate students? Turns out, graduate students often have insufficient competencies to teach engineering design. We explored this further using educational psychology as a backbone. In doing so, we turned to a learning model in Bloom's taxonomy in the cognitive domain. Bloom's model describes the staged learning process one undertakes as they proceed in learning a new subject. Learners start at the bottom of the pyramid as a novice, developing the basic competencies or knowledge of the facts, terms, and concepts. Once the competencies in this tier are acquired by the learner, he/she proceeds upward into the next tier. This happens until the learner eventually reaches the synthesis stage, when he and she is in fact creating new knowledge in the domain. At this point, the learner is considered as obtaining mastery of the subject. In essence, Bloom's taxonomy describes how we learn. An interesting publication by Terry and Harb in 1999 attempted to describe the process of learning engineering design using Bloom's taxonomy. In their work, they described the engineering science model, for which most engineering courses are taught, residing in the bottom 3 tiers. In contrast, the competencies required to successfully learn engineering design resided in the upper 3 tiers. This work established a set of general competencies required to perform engineering design. From this information, we can make an argument that these are the same set of competencies required by our graduate students for them to successfully teach engineering design. This established a clear set of learning outcomes we could use in developing a training protocol for our graduate students to teach design. Our solution was the development of the Design Engineering Mentorship Program, or DEMP for short. This is a week-long experiential-based training program that focuses on the development of specific competencies in graduate students in order for them to support undergraduate design curriculum. This is an experiential-based program, so it focuses not only on learning the associated theory, but also practicing the specific skills in order for graduate students to be successful. Graduate students also, in addition to attending specific workshops, are required to create and deliver their own design project for which they deliver to a group of students that they don't know. At the end of the week-long training program, the graduate students that complete it successfully are certified as Design Teaching Assistants, or DTAs. In the context of specific competencies, we group them into what we labeled our 4 pillars. This includes knowledge of the design process, the ability to deter poor group work through coaching, supporting the development of a creative working environment, and specific domain knowledge. In the context of DEMP, the top 3 pillars are addressed by our training protocol, whereas domain knowledge varies with the individual. So our program level objectives are to develop a clear understanding of what engineering design is, to learn about how creativity plays an integral part in engineering design, to learn about the role of coaching and to practice specific techniques that are related to coaching, to develop a design project from ground up, to deliver that design project as a coach to a student group and obtain their feedback, and finally to reflect on your teaching experience and to develop insight on how to improve in the future. So how is the program structured? In the week prior to the program, a reading assignment is disseminated and completed via a handout. The content includes a description of the differences in engineering design versus engineering science, the generation of design problem statements, and the description of a general design process. In the first day and a half of DEMP, graduate students attend 3 experiential-based workshops on an introduction to engineering design, creativity through divergent inquiry, and coaching and facilitation. This is followed by 2.5 days in which graduate students work in teams to develop their own design project from scratch, including test and iteration cycles, creation of a short project pitch, as well as an assessment protocol to determine whether students are successful in their challenge. Finally, on the last day, graduate students deliver their design projects to their student groups and solicit feedback, and finally reflect on their experiences. Now a little bit about our team. Our team consists of 4 individuals, myself as a DEMP program manager and instructor, Alex Demopoulos as a program developer and instructor, Rosalind Gates as a professional coach and instructor, and finally Dr. Peter Wild, who is our NSTRIC chair in design engineering. Moving on, we describe each of the workshops in a bit of detail. Workshop 1 is on engineering design basics. In this workshop, graduate students learn how to clearly distinguish the difference between engineering design and engineering science. They learn about a simplified design engineering process. They practice generating problem statements for design projects in 2 activities. The first is the conversion of science statements, which they are well familiar with, into design project statements. And the second is they are provided with a scenario which they need to analyze, extract information, and generate a problem statement. And finally, we have the graduate students experience firsthand the execution of a mini design project. But of course we do this with a twist. In the first case, we present them with a poorly defined project. The goal is for graduate students to experience firsthand the frustrations of executing a poorly defined design project, with the hopes of appreciating an undergraduate's experience in executing a similar project. In the second case, the same project is executed but is well defined. At the conclusion, we have graduate students contrast their experiences through discussion. Workshop 2, Creativity through Divergent Inquiry. In this workshop, graduate students understand the role of creativity in engineering design. They learn that creativity is a learned skill and that it can be developed. They learn about the importance of divergent and convergent thinking. They learn about environmental conditions which provoke creativity. And then they practice techniques to spur idea generation through the use of creative frameworks. And in particular, in this workshop, we use brainstorming affinity. And the motivation is to generate numbers of project ideas. So we ask them to generate tens of project ideas, and at the end, students work together to refine and finally select a few suitable projects. More details about the creativity framework. We have graduate students work independently first to define physical principles on cue cards. For example, heat transfer, and then we combine these as a class, and then we randomly place these principles onto chart paper. We then have graduate students work in groups, and using these principles in their group, they generate related ideas, and then they affix those to the chart paper. So an example of some ideas related to heat transfer are thermocouples, fins, and fans. We have the student groups rotate until all the chart paper is full. And then we have groups who work with those principles and ideas on each of the charts to sketch out a scenario. So an example of sketching a scenario out with the information, the ideas and principles we've listed above is we could have a metal plate that is heated by a Bunsen burner that needs to be maintained at a specific temperature through the use of a combination of fins and a fan, where the thermocouple is used to measure the temperature. Finally, once we have numerous scenarios sketched out on paper, our students work in groups to generate problem statements from those scenarios. The fundamental component of this creativity framework is to limit time, to prevent fixation. And so by preventing fixation, graduate students are forced to come up with quantity of ideas as opposed to quality. Workshop 3, Coaching and Facilitation. This workshop is facilitated by Rosalind Gates, our professional certified coach. She introduces coaching as a method to facilitate a creative mindset. And mindset is a key word that we're going to discuss later. We have our graduate students experience and examine the group dynamics in the creative process, and we have them practice using a coaching framework to facilitate design projects. In this workshop, graduate students learn about the role of a coach as a facilitator of the design process. They're not there to tell the undergraduate students what to do, but rather to facilitate the process. We discuss the learning continuum and the difference between pedagogy and andragogy, where pedagogy is more focused on teacher-directed and andragogy is more focused on self-directed. Engineering design leans towards the self-directed side of the learning continuum. We discussed the judge-or-learner model, which is a choice model describing mindsets that frame our view. And we learn that the coach's role is to encourage the learner model through facilitation. This is followed by coaching tools, in which we present STEM sentences, which are open-ended questions to engage self-directed thought. For example, who else feels similarly? We present the graduate students with a set of canned STEM sentences that are applicable to any circumstance. As well, we have graduate students generate their own domain-specific STEM sentences. We do this also for best practices. For example, test early and test often, and graduate students are encouraged to do the same within their own domain. And finally, we practice using these tools through guided activities. In terms of coaching activities, the first is contrasting facilitation styles, where we use a good coach, bad coach approach, in which we split the class into two distinct groups. Half the class works on a project with a good coach who uses positive coaching techniques, while the other half works on a project with a bad coach. We have the groups switch projects and discuss their experiences through a reflection period. The second activity is a puzzle game in which a team member is blindfolded and relies on their teammates to communicate in a clear and supportive manner. The key here is for the graduate students to learn the communication must be both clear and supportive. The third activity is an interactive coaching demonstration in which Alex and I act as undergraduate students executing a design project. Conflict arises between us, and Rosalind, our coach, acts as our design facilitator. However, since this is a demonstration to the entire graduate student class, she uses them to solicit suggestions on both identifying the conflict and how to facilitate it through the use of coaching strategies. The last activity, the graduate students work in teams for which one individual gets practice as a coach. A design problem is assigned, but there is a twist once again. The coach is provided additional information as a predefined solution. The goal of the coach is to facilitate the design process without pushing the suggested solution. Design Project Challenge. Development of the design project follows a systematic framework for execution. This framework includes the development of concise learning outcomes for their projects, establishing scope, developing a bill of materials, building and creating several prototypes, and teaching their project internally and gathering feedback for iterative refinement. This includes technical process and coaching feedback. They create documentation describing their project, and they need to create a pitch laying the foundation for student execution. Finally, the design project delivery. This is the final day in which DTAs deliver their project in 30 to 45 minute periods to 3 different groups of students. They act in the role as a design instructor, facilitating the design project to these students. They support students in assessing success in accomplishing their design challenge. And finally, they reflect on their experiences in 2 different ways. They look at whether the students responded in the ways that they expected, and they look at ways in which they can improve their project in the future. In summary, we described our challenge as a need to develop competencies in graduate students so they may support teaching undergraduate design curricula. We presented the new Design Engineering Mentorship Program as a week-long intensive program to possibly address our challenge. The DEMP program includes 3 experiential-based workshops and a design project in which graduate students gain both practice in developing and delivering a design project in the role as a coach. That's all I have for today. Thank you very much for watching. As mentioned previously, the full paper for which this presentation is based may be found on my ResearchGate page. The URL has been provided in the video description below. Please leave any comments you may have on my research on ResearchGate. If you found this video helpful, please hit the like button and subscribe to be notified when future videos are posted. Thanks again.